Hello everybody, my name is James Pruitt. This is my 9th lecture on JavaScript. We're still constructing our large integer data type, so let's get with it. We finished off the construction part. Now we're going to talk about the integer part. We've constructed, so we've filled in the value of radix and number and negative, and they're going to be fixed now once we've converted initializer into those values. And when integer is called, when we're calling this to construct a new integer, it creates, every time you apply a function, it creates a new environment. And so these values get put in this new environment. And so when we call integer again, it's going to create a brand new, different environment from the one we created this time. So what we've done, we have a constant now. Those guys are constant, and only people that can access, only thing that can access is from this function right here. Oh, actually not this function. Well, this function can, but from this function, we're going to return this function. And this function is going to be what we think of when we think of an integer. So an integer is a function. So and we take in messages. So we have two types of messages. Our message can either be a string or a number. If it's neither of those two, then we're going to throw an error. So if it's a string, if it's a radix, we're going to return radix, the radix value. If it's digits, the string digits, we're going to return number.length. If it's a string type, we're going to return integer. If it's toString, which is the complicated one, we're going to convert our integer to a string. And this is important because when you want to troubleshoot, you need to be able to get data see what our integer is, what's going on. We need to be converting things to strings so we can print them out, so we can read what's going on. If it's a number, and if it's a decimal number, it has a decimal point, we're going to throw an error. If it's negative, we're going to throw an error. If it's greater than the number.length, we're just going to return 0. Else, if it's between 0 and if it's in less than the length, it's just going to actually return the digit. So that way we can use those digits, each of which range from 0 to 2 to the 26, in our algorithms to multiply, add, subtract, divide, remainder. Okay, so let's look at this string part. And if I come over here and I just want to give you an example. Just make sure my is resized correctly. Okay. Now, if you think our numbers are to the base, we're doing base. Our number system is the base 2 to the 26. Now, just think of a 10-digit base. For a base 10, I want to show you how do you. So if I have a number that's 1, 2, 3 to the base 10, where this is the ones place, tens place, hundreds place, and I want to figure out convert this to a string. This is just a number. I could divide by 10, and I could divide by 10, and you're going to get that's equal to 12, right? And I can take 123 mod 10, and that's equal to 3. So we would write it in object form as q dot 12 and r 3. This is how I'd write it. And then I could come back and take this q value here, this q value, and then I can repeat that process. So we go q is 12 divided by, and this is going to be floor. I forgot to say this is the symbol for floor, and that's the largest integer less than this number. Since this number is positive, the largest integer less than this number. So we've got floor 12 divided by 10, and that's going to equal to 1. And then we're going to come over here to r, which is going to be 12 mod 10, and that's going to be equal to 2. And then we can put, we do the q, again, we take that 1, which is the floor of 1 divided by 10, and that's equal to 0, and we're going to terminate our process here, and r is going to be 1% 10. We're going with a q here. We go off a q. So r is 12% 10, 123 or mod 10, and that's equal to 1. So what we do is we going to have accumulator string, and we're going to say string is equal to the empty string, and then we're going to say string is equal to the string 3 append empty string, and then we're going to say string is equal to, and that's equal to string is going to be equal to just 3. And then we're going to say for the second case 2 append string, and that's going to be equal to 2, 3. And then we're going to say string is equal to, and that's where we're done. String is equal to string 1 plus string, and that's equal to the string 1, 2, 3. So you can see the algorithm. That's how the algorithm is going to go. Let's see what time it is. We'll push that up here. Let's see, where's my notebook? Okay, so that's how it's going to go. We're going to set q equal to the number, and if q.length is equal to 1, and q the least significant digit is 0, so that means we have a 0. We just return 0. Now this is our accumulator, like I described. While q, this is what it means for q to be 0. While q is not 0, we say temp is equal to divide by 10 q. And what temp will divide by 10 will return a q value, a quotient value, and a remainder value. So we got string is equal to temp.r append string, and q is equal to the next q, and we repeat that process until q is 0, and therefore that gives us the magnitude. If it's negative, we append the negative sign to our string, and then we just return our string. So that's simple enough. The difficult part is just divide by 10. And this is a helper function, and only this is not accessible from outside our this function environment. So this environment here from outside of integer, this divide by 10 is not accessible. So we have a dividend, and we want to make sure we don't change that dividend. So if we have to make sure that this dividend doesn't occur on the left hand of the side of the equal sign of the assignment operator. So we don't assign nothing to dividend. Okay, so now here q is equal to 0, and this is our quotient, and this is our remainder is equal to 0, and this is our temporary variables a and I, and we say that for I equal to dividend.length minus 1, so this is the most significant digit, and I is greater than or equal to 0, we're going to go decrement I. Let me pull this up, and we'll write this algorithm up real quick. So what we want to do is we're going to have something like this. We have a number, and it's A0, A1, A2, A3. And again, this is equal to A3 times 2 to the 26 cubed plus A2 times 2 to the 26 squared plus A1 times 2 to the 26 plus A0. And what we're going to do, we're going to write that. We're going to say 10 is going to divide into A3, A2, A1, A0. So this is this guy ranges, A3 ranges from 0 to 2 to the 26. So 10 goes into that. We're going to say Q1. Q1 times 10 minus A3, that's going to give us a remainder of 3. And then we're going to, and that remainder is less than 10. Remainder is less than 10. And then we're going to bring down to A2. So this value right here is going to be our A. This value here is going to be our A. I'm going to set that equal to A, and then we're going to set that equal to A. And then we divide 10 into that. And that's going to give us another Q2, and that's going to give us an R2. And then we bring this A1 down, and we set that equal to A. And that's going to be Q1, and that's going to give us a remainder of 1. And then we bring the A0 down, and we set that equal to A. And then we're going to divide 10 into that, and that's going to give us a quotient of 0, and with a remainder of R. And then we're going to return, our Q value of Q0, Q1, Q2, Q3, right? And as we go along, if Q3 happens to be 0, we want to decrement this array, and you do that by decrementing the length. Decrementing the length will pop this guy off. So if I say, I'll show you on this in 1 second, and then we return R. And before I go back to our code, let me pull up this CA. And if I say JS, get my JavaScript running. So if I say X is equal to an array of 1, 2, 3, 4, right? And then we can say X.length, and we can see that that's 4. So if I say that I decrement X.length, and what I've done is I popped 4 off of that array. So now if I say X, I've got 1, 2, 3. Okay, so keep that in mind. So when we come over here, and we're going to, if the Q3 is 0, we're going to pop that off. If Q2 is 0, pop it off. So we have no leading zeros. Our most significant digit is not 0 in our representation. So we come back to our code, and we look at this, and we say that to start off with, we set R equal to 0. So this dividend I is just A3, right? This is the most significant digit, and we set that equal to A, like we talked about. And if A is equal to 0, if dividend is equal to 0, we set QI equal to 0. And then we're going to decrement. A is equal to dividend, decrement I. Because if A is equal to 0, R has to be equal to 0, right? So A is just going to be dividend, decrement I. If I is equal to 0, that means we're at the least significant digit, and we're done. So we can't decrement below 0, our index. Then this little code statement is we're looking at if q.length is greater than 1 and q of q.length minus 1. This is the most significant digit. If that's equal to 0, we're just going to decrement, pop that off until we got a non-zero leading term, or that the length is 1. If length is 1, then we allow the most significant digit to be 0 because the whole q is 0. Then we return q r. Okay, so we've got past that. And then we look at this. If a is less than 10, then we set qi equal to 0. If I is equal to 0, we do the same thing, pop off the leading zeros and return q, q, and ra, because I is 0. We're done. We can't decrement I anymore. But if I is not equal to 0, we've set qi equal to 0, and then now we're going to move on down. We're going to say a is equal to a times radix plus dividend minus I. Okay, so now we've taken care of that case. Now we know that a is greater than 10, right? From there, a is greater than 10. So we can say that qi is equal to math.floor of a divided by 10. And r is equal to a mod 10. So r is the remainder. This is the quotient. This is the quotient. And then r is the remainder of 10. And then we repeat that process just like I described. We set a equal to r times the next dividend. If you see down here, actually you see in the for loop, we've decremented the I here in the for loop. So we brought down to the next, just like we did right here. We keep on pulling down R3, A2, R3 times radix plus A2, R2 times radix plus A1, R1 times radix plus A2. And that's how that worked. So we come down here, we did our division, and we repeat that process until we get down to the last digit. I is greater. If I is equal to 0, we do it one more time, and then we pop it off. If I is equal to 0, we do it one more time, and we pop it off. Okay. If this is again pops off the leading zeros, and then we return our QR. And that's it for our large integer, the basic constant form. Now we can start with our algorithms for addition and multiplication. Thanks a lot. Bye.